geometry. Introduction. You are familiar with a number of shapes. You learned how to draw some of them in the earlier classes. For example, you can draw a line segment of given length, a line perpendicular to a given line segment, an angle bisector, a circle, etc. Now, you will learn how to draw parallel lines and some types of triangles. Construction of a line parallel to a given line through a point not on the line. Let us begin with an activity. 1. Take a sheet of paper. Make a fold. This fold represents a line L. 2. Unfold the paper. Mark a point A on the paper outside L. 3. Fold the paper perpendicular to a line such that its perpendicular passes to A. Name the perpendicular AN. 4. Make a fold perpendicular to this perpendicular through the point A. Now, the perpendicular line as M. Now, L is parallel to M. Do you see why? Which property or properties of parallel lines can help you? Which property or properties of parallel lines can help you? Here to say that the lines L and M are parallel. You can use any. One of the properties regarding the transversal and parallel lines to make this construction using ruler and compass is only 1. Take a line L and a point A outside L. 2. Take any point B on L and join B to A. 3. With B as center and a coordinate radius, draw an arc cutting L and C and B at D. 4. Now with A as center and same radius and step 3, draw an arc EF cutting AB at G. 5. Place the pointed tip on the compasses at C and just the opening so that the pencil tip has D. 6. With the same opening as in step 5 at the G is center, draw an arc cutting the arc EF at H. 7. Now join AH to draw a line M. Note that angle ABC and angle BH are interrelated angles. Therefore, M is parallel to L at A. Construction of triangles. It will be better for you to go through this section after recalling ideas on triangles, in particular the chapters on properties of triangles and congruence of triangles. You know how triangles are classified based on sides of angles and the following important properties concerning triangles. 1. The exterior angle of the triangle is equal in measure to the sum of interior opposite angles. 2. The total measure of the three angles of the triangle is 180 degrees. 3. Sum of the lengths of any two sides of the triangle is greater than the length of a third side. 4. If any right angle triangle, the square of the length of hypotenuse is equal to the sum of the squares of lengths of the other two sides. In the chapter on congruence of triangles, we saw the triangle if we can draw any one of the following sets of measures are given. 1. 3 sides. 2. 2 sides of the angle between them. 3. 2 angles and a side between them. 4. The hypotenuse and the leg in the case of a right angled triangle. We will now attempt to use these ideas to construct triangles. Constructing a triangle with the lengths of its 3 sides are known. In this section, we would construct triangles and when all its sides are known, we draw first a rough sketch to give an idea of where the sides and are. They begin by drawing any one of the 3 lines. See the following example. Construct a triangle ABC given that AB is equal to 5, BC equals to 6 cm and AB equals to 7 cm. Steps of construction. 1. First we draw a rough sketch with given measure. This will help us in deciding how to proceed. 2. Draw a line segment BC of length 6 cm. 3. From B point A and distance of 5 cm. So with B as center, draw an arc of radius 5 cm. 4. From C point A is at a distance of 7 centimeter. So with C as center, draw an arc of radius 7 centimeter. 5. A hash to be brought the arc stone. So it is a point of intersection of arcs. Mark the point of intersection of arcs as A. Join AB and AC. ABC now is ready. We observe that angle DAF exactly coincides with angle ABC. Note that the triangles have been constructed when the three sides are given. Thus, if three sides of one triangle are equal to the corresponding three sides of another triangle, then the two triangles are congruent. This SSS congruency rule we have learnt in our earlier chapter. Constructing a triangle when the lengths of the two sides and the measure of the angle between them are known. Here we have two sides given and one angle between them. We first draw a sketch and then draw one of the given line segments. The other steps follow. See example 2. 2. Construct a triangle PQR given tan PQ equals 3 cm, QR equals to 5.5 cm and angle PQR is equal to 60 degree. Steps of construction. 1. First we draw a rough sketch with given measures. 2. Draw a line segment QR of length 5.5 cm. 3. At Q, draw OX making 60 degree with QR. 4. To fix P, the distance QP have given. With Q as center, draw an arc of radius 3 cm. It cuts QX at point P. 5. Join PQR. PQR is now obtained. Constructing a triangle when the measures of the two of its angles and the length of a side between them is given. As before, draw a rough sketch. Now given a line segment, make angles on the two ends. See this. 3. Construct angle XYZ. Fix given that XY equals 6 cm, M angle XCY equals to 30 cm and M angle XYZ equals to 100 degree. Steps of construction. 1. Before actual construction, we draw a rough sketch with measures marked on it. 2. Draw XY of length 6 cm. 3. At X, draw ray XP, making an angle of 30 degree with XY by the given condition Z. Must be somewhere under XP. 4. At Y, draw array YQ, making an given angle of 100 degree with YX. By the given condition, Z must be in array YQ also. 5. Z has to lie on both the rays XP and YQ, so the point of intersection of the two rays is Z. XYZ is now completed. Constructing a right angle triangle when the length of one leg and its hypotenuse are given. Here, it is easy to make the rough sketch. Now, draw a line as per the given side. Make a right angle on one of its points. Use compasses to mark length of side and hypotenuse of the triangle. Complete the triangle. Consider the following. 4. Construct angle element. Right angle at M. Given that Ln equals 5 cm and Mn equals to 3 cm. Steps of construction. 1. Draw a rough sketch and mark the measures. Remember mark the right angle. 2. Draw Mn of length 3 cm. 3. At M, draw Mx equals Mn. L should be somewhere on this perpendicular. 4. With N center, draw an arc of radius 5 cm. 5. L has to be on the perpendicular line MX. As well as on the arc, draw with center N. Therefore, L is the meeting of its two. LMN is now obtained. What have we discussed? In this chapter, we looked into the methods of some ruler and compasses constructions. 1. Given the line L and a point not on it. We use the idea of an equilateral triangles in a transversal diagram to draw a line parallel to L. We could also have used the idea of equal corresponding angles to draw the construction. 2. We study the method of drawing a triangle using indirectly the concept of congruence of triangles. The following cases were discussed. 1. SSS. Given the three-side length of a triangle. 2. SAS. Given the lengths of any two sides and the measure of the angle between the sides. 3. ASA. Given the measures of two angles and the length of side included between them. 4. RHS. Given the length of hypotenuse of the right angle triangle and the length of one of its legs.